All right, let's look at the homework 6.2, problem number 7. All right, so let's find the volume of a cap of a sphere with radius r and the height h. All right, so I'm going to use the disk method. All right, so first I'm going to draw a circle with radius r centered at the origin. All right, then it's going to go from r minus h to r. Then we look at this region under this curve, which is a top semicircle, whose equation is, we can actually derive it from the equation of the circle. Equation of the circle with radius r is x squared plus y squared equals r squared. Then we can just solve for y. So you have a y squared is equal to r squared minus x squared. All right, then we can just take the square root of both sides. Then we get the y is equal to plus or minus square root of r squared minus x squared. All right. In this case, we're talking about the top semicircle. So the top one, so this curve right here is y equals the positive square root of r squared minus x squared. All right. So I'm going to use the disk method. So we have, so we're going to just think of some random x value here. All right. Then you can see that the cross section is going to look kind of like this. All right. So you have a disk right there. All right, so we're going to use the disk method. So this is going to be a volume, so V. All right, so disk method always has a pi in front. Then integral is going to go from r minus h to r. All right, so you have a r minus h to r. Then we just have to have a radius squared, and the radius is determined by, so it's from here to there, so it's just a square root of r squared minus x squared. Right? Then you just have to square that with respect to x. Right? So luckily we can just cancel square and the square root. So all you have to do is evaluate this integral. Pi times integral from r minus h to r. Then you have r squared minus x squared with respect to x. All right? I'll let you guys finish it up. All right? That's it. I hope that this was clear.